In this lesson, we're going to learn how to solve quadratic equations using a process known as completing the square. If you're unfamiliar with completing the square, you may want to review my video on writing quadratic functions in vertex form by completing the square, where I go through this process in even greater detail. You might also find my video on solving quadratic equations in vertex form a little bit useful. So let's take a look. Why do we need a new process for solving a quadratic equation? We've learned already that we can solve quadratic equations by factoring. And when we rewrite the equation in factored form, that we take each of the factors, set them equal to 0, and we get the solutions to the equation. That process has served us very well up to this point. So why another method? Well, sometimes we can't factor. Take a look at this equation. X squared minus 2x minus 6 equals 0. When I try to factor this, I'm looking for numbers that multiply to negative 6 and that add to negative 2. I can list out 4 pair of numbers that multiply to negative 6. But when I look at them, none of those pairs add to negative 2. There are no integers that meet both criteria. The trinomial can't be factored, so we cannot solve by factoring. We have to use another method. And fortunately, there are several methods. Options would include completing the square or using the quadratic formula. In this video, we're going to look how we can use completing the square in order to solve a quadratic equation. Let's continue with the equation that we just saw that couldn't be factored. X squared minus 2x minus 6 equals 0. To complete the square, we begin by adding the boxes. X squared minus 2x plus the box minus 6 minus the box equals 0. I can put any number into the box that I want as long as both boxes get the same number. But I want a specific number that will make the trinomial a perfect square trinomial. To find the number that goes into the boxes, I take half of the middle term, negative 2. Half of negative 2 is negative 1. I square that result, and I get positive 1. Positive 1 is the number that goes into the boxes. Now, I can take the x squared minus 2x plus 1 and factor that into x minus 1 all squared. Negative 6 and negative 1 is minus 7 equals 0. And now I have an equation in vertex form that I can solve by using inverse operations, or SADMAP. I begin with my subtraction and addition. We have subtraction of 7, so we add 7 to both sides of the equation. We now have x minus 1 squared equals 7. The next step is to look for division and multiplication. There is no division or multiplication in this equation, so I move on to the next step of dealing with the exponents. We do have an exponent. We have x minus 1 to the second power. The inverse of squaring is taking the square root, so I take the square root of both sides. On the left, the square and the square root will cancel out. On the right, don't forget the plus or minus in front of the square root of 7. Now I have x minus 1 equals positive or negative square root of 7. The square root of 7 does not simplify, so I'll leave it as it is. The final step is to deal with the parenthesis. In the parenthesis, I have minus 1, so I'll add 1 to both sides. X equals 1 plus or minus the square root of 7. Remember, that gives me two possible solutions. X equals 1 plus the square root of 7, and x equals 1 minus the square root of 7. Those are the solutions, and this is how they should be written with the square root in place. If you feel uncomfortable with the square root because you're not quite sure what those numbers are approximately equal to, you can always check in your graphing calculator. 1 plus the square root of 7 is around 3.6. 1 minus the square root of 7 is approximately negative 1.6. These are irrational numbers, so the decimals go on endlessly forever. Don't use the rounded solution unless you're asked to. It's always best to stay exact, leaving the square root in place. An interesting note is this. When factoring is not possible, the solutions will be irrational. In other words, if you can't factor the trinomial, then your solutions to the equation will contain square roots. Let's work through a couple of examples. We want to solve the equation x squared plus 8x plus 8 equals 10. Remember that this equation must first equal 0, so we'll have to make it equal 0 first. If you feel comfortable that you can solve this equation on your own, now's a great time to pause the video. If you're not quite sure and you want to work through another example together, stay with me and we'll go through it together. The first step is to subtract 10 from both sides so that the equation is equal to 0. Now I'm curious, can I solve this equation by factoring? We would need numbers that multiply to -2 and add to 8. The pairs of numbers that multiply to -2 are -1 times 2 and 1 times -2. Neither of those pairs of numbers add to 8, so this trinomial is not factorable. I need another method. We'll use completing the square, and then we'll use inverse operations, or SADMEP. To complete the square, we'll set up our equation with the box, x squared plus 8x plus the box, minus 2 minus the box, equals 0. Now we'll look at the trinomial, the first three terms. We need to find the number that goes into the box. We take half of the number in front of x, which is positive 4. We square it, and put that number, 16, into each of the boxes. Now, we can rewrite our function, or equation rather, in vertex form. We have x plus 4 squared minus 18 equals 0. We now have the vertex form of the equation. Now we'll follow inverse operations, or SADMEP. We begin by looking for subtraction and addition. We add 18 to both sides of the equation. X plus 4 squared equals 18. Now we look for division and multiplication. There is none, so we move on to the next step, exponents. We do have an exponent. We have x plus 4 squared. The inverse of squaring is taking the square root, so we take the square root of both sides. On the left, the square and the square root cancel out. On the right, don't forget the plus or minus in front of the square root of 18. That leaves us with x plus 4 on the left, and we have the square root of 18, which we must simplify. The largest perfect square that goes into 18 is 9. 9 times 2. The square root of 9 is 3. So the square root of 18 is 3 square roots of 2. So x plus 4 equals positive and negative 3 square roots of 2. The last step is to deal with the parentheses. In the parentheses we have plus 4, so we subtract 4 from each side. X equals -4 plus or minus 3 square roots of 2. Remember, you can leave your solution like this, or you can write it as two separate solutions. X equals -4 plus 3 square roots of 2. X equals -4 minus 3 square roots of 2. Be careful not to make common mistakes. Do not combine unlike terms, and be sure to leave the square root in your final answer. If you want a feeling for what those numbers are approximately equal to, you could always type them into your graphing calculator to get an idea of where those numbers would lie on the number line. Here's an exercise for you to try. X squared plus 18x plus 18 equals 9. Can you solve this equation by completing the square? Remember, the equation must equal 0 first. Please pause the video here and come back when you're ready to check your answers. Let's compare answers. We need our equation to equal 0, so we begin by subtracting 9 from each side. X squared plus 18x plus 9 equals 0. I'm curious if I could factor. If I factor, I'm looking for numbers that multiply to 9 and that add to 18. I find 4 pair of numbers that multiply to 9, but none of them add to 18. This trinomial is not factorable, so I'm going to have to use completing the square. I set my equation up with the boxes. X squared plus 18x plus the box plus 9 minus the box equals 0. I look at the trinomial, which consists of the first 3 terms. I take half of the middle number, half of 18 is 9, and I square it to get 81. 81 is the number that goes in the boxes. Now I can rewrite this in vertex form. X plus 9 squared minus 72 equals 0. And now we can use our inverse operations, SADMAP, in order to solve the equation. We begin by looking for subtraction or addition. We have minus 72, so we add 72 to both sides. Next, we look for division or multiplication. There is none, so we move on to the next step, which is the exponents. We have x plus 9 to the second power. The inverse of squaring is taking the square root. On the left, the square and the square root cancel out. On the right, don't forget the plus and minus in front of the square root of 72. That leaves us with x plus 9 on the left, and on the right, we have to simplify the square root of 72. The largest perfect square that divides 72 is 36, so we have 6 square roots of 2. X plus 9 equals positive and negative 6 square roots of 2. Finally, deal with the parentheses. In the parentheses, we have plus 9, so we subtract 9 from each side. X equals negative 9 plus or minus 6 square roots of 2. Be sure to leave your answer like this, where you have the square root in place. If you want to see what those are approximately equal to as far as decimals go, you can always type them in your calculator, but again, never use the rounded solutions unless specifically directed to. A common question that I'm asked is, now that we know we can use completing the square to solve an equation that isn't factorable, can we use it to solve an equation that can be factored? Well, the answer is yes. Consider the equation x squared minus 10x plus 20 equals 4. To solve this equation, we first have to set it equal to 0, so we subtract 4 from both sides. This actually is factorable. Numbers that multiply to 16 and add to negative 10 are negative 8 and negative 2. I could very easily rewrite this in factored form and then solve each factor set equal to 0 for x, finding that x equals 8 and x equals 2. It's actually a fairly simple equation to solve. But you could use completing the square if you really wanted to, and you will come up with the same solutions. Allow me to show you. If we wanted to use completing the square, we would first set up the equation with plus the box and minus the box. Then we would have to figure out the number that goes into the box. Half of negative 10 is negative 5. Squared is 25. So the number that goes into the boxes is 25. Now I can rewrite this in vertex form. X minus 5 squared minus 9 equals 0. And I'm ready to use my inverse operations, SADMAP, in order to solve the equation. First I deal with subtraction and addition, so I add 9 to both sides of the equation. X minus 5 squared equals 9. Next I look for division and multiplication. I don't have any, so I move on to the next step of exponents. I have the second power, and the inverse of squaring is taking the square root. On the left-hand side, the square and the square root cancel out. On the right-hand side, don't forget the plus or minus in front of the square root of 9. We now have x minus 5 equals, and the square root of 9 is 3, so positive or negative 3. Now we deal with the parentheses, add 5 to both sides, which results in x equals 5 plus or minus 3. These are two possible solutions. The first is x equals 5 plus 3, which means x equals 8. Notice that matches what I found by factoring. The second possible solution is x equals 5 minus 3, or x equals 2. Again, notice that matches the solution that I found by factoring. So the moral of the story is this. You can use completing the square whether you can factor or not. However, factoring tends to be considerably less work, so it's beneficial to use it when possible. Let's end with one last exercise for you to try today. X squared minus 8x minus 12 equals 8. This is an equation that can be solved two different ways, by completing the square and by factoring. I encourage you now to try to solve it both ways. See if you can come up with the same solutions. Take a few minutes to do that, and when you're ready to compare answers, come back and we'll see how you did. Let's compare answers. The first step in solving any quadratic equation is making sure that the equation is equal to 0. We subtract 8. X squared minus 8x minus 20 equals 0. Let's start by factoring. We need numbers that multiply to negative 20 and add to negative 8. Those numbers are negative 10 and 2. So we can rewrite the equation in factored form, x minus 10 times x plus 2 equals 0. Set each of those factors equal to 0 and solve. X equals 10 and x equals negative 2. We found the solutions, and really we're done with the problem, except that I asked you to also try completing the square. So let's take that factored form and let's put that down at the bottom here, and let's solve the equation again, this time using completing the square and inverse operations. We set the equation up with the boxes, x squared minus 8x plus the box minus 20 minus the box. We look at the trinomial made up by the first three terms. We take half of the middle term. Half of negative 8 is negative 4. Squared is 16. So 16 is the number that we put in the boxes. Now we have x minus 4 squared minus 36 equals 0. Now we follow SADMEP, the inverse operations. We begin by dealing with subtraction and addition, adding 36 to both sides of the equation. Then we look for division and multiplication, which we don't have in this problem. Next, we deal with the exponents. The inverse of squaring is taking the square root. We do that to both sides. On the left, the square and the square root cancel out. On the right, don't forget the plus or minus in front of the square root of 36. On the left, we have x minus 4. On the right, we have plus or minus 6. The final step is to deal with the parentheses. Add 4 to both sides. X equals 4 plus or minus 6. Remember, this is two separate solutions. X equals 4 plus 6, which is 10. Notice that matches what we found by factoring. And x equals 4 minus 6, which means x equals negative 2. And once again, notice that that's exactly what I got by factoring. So if you have a factorable equation, you could use completing the square, or you could use factoring. Let's end with one word of caution. This process of completing the square really only works if the leading coefficient is 1. If you had, for example, a 2x squared, then you would have to deal with that a little bit differently, and we'll discuss that in a future video. Now you know everything you need to know in order to begin solving quadratic equations by completing the square. Remember, there's a step-by-step guide in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.